Hello, this is Team 4, and we would like to share our presentation about how economic and culture status are relevant. So this is like a preview of our analysis. So we basically use economic data and cultural data, which is basically big data, and then like by using this, we're gonna invest in meaningful regressions. For the economic data set, we chose detailed flight log and other additional data set, which we can see that might relevant to cultural activity level.
Okay. From now on, I'm gonna do presentation after Inger. For economic data analysis, before other teammates do in-depth analysis with cultural data set, I'm more focused on economic data set and financial data set, how it works. We use for the architecture we already shown below. In previous slide, we use PySpark, and also we are utilizing various database. And also for the further structure, we split the low data set and the process data set. And for low data set and everything, we will also show it later. We can see it in our local host website, so we can easily see it. For data set, we can differentiate it between real-time data set and just sentimental text data set and economic data set related with time series. For data collection, for economic data set, we collected followings using News API and Yahoo Finance, and also the others. This is how data flows looks like from Yahoo Finance and News API. We crawl the things, and it will be processed with process metric like stock return 1 year index and company average return and news article, YouTube engagement, social sentiment, and so on. And it goes to composite score. Oh, I will tell you later again, but basically real-time data set, there was problem, which was we already collected more than 40 gigabyte, but we didn't really show meaningful result. We kind of concluded that using real-time data to do big data analysis is really difficult. And like how big tech company do, we need more than petabyte data scale. So we give up real-time data and we change it to stock data news headline and economic data and World Bank that they provide 20 years and 40 years past data. So this is just very brief how we collected and how we um, configure the data set. This is the part how we use PySpark to connect with other database. And we use data load PySpark function to load data, and we aggregate and we did some pre-processing. This is after what this is the various way of processing we did it. PageRank algorithm and granular causality and NTP specific price correlation is what we all did. And this is also one of the processing very specific algorithm. We use PageRank to make word graph. And this is our visualization result. Right side is correlation metrics, and left side is how return and sentiment word is related. And this is also word graph. And if you see the left side, this is our visualized website, and there's also word analysis graph. There is kind of meaningful result. We will talk about it later. First insight is, like I already talked about, like failure of using web socket data. Like we used more than 40 gigabyte for collected it for more than 4 days or 3 days, but we failed to make meaningful data. So we moved to the data that already were processed and some we can easily get from API. So some meaningful result is that market street has more than 40% weight than others, which is market are shown in target word and source word. So we can interpret it as people think market over government and company. Uh, and another thing is in market in terms of our super come out a lot in use, but not in YouTube, the term of market, which is people are more interested in meta or such individual stuff than market. This is kind of a bit different result. In newspaper, there are more words come out such as Fed, market street, but in word that actually people use is Meta or such private company. And also there was some interesting analysis which was there was 13 word come out a lot. Then after that, after the day after tomorrow, that stock price increase such as blockchain or healthcare.
Our project aims to quantitatively measure cultural activities and cultural exchange levels across countries. To achieve this, we selected three large-scale datasets: GDAL, OpenSky flight logs, and Wikipedia dump. Initially, we attempted to use OECD culture expenditure data, but during the mid-evaluation, we received feedback that the dataset was too refined, too small in volume, and unsuitable for a big data processing pipeline. Therefore, we shifted toward more raw, large-scale, and culturally relevant data sources, leading us to adopt OpenSky flight logs and the Wikipedia dump. GDELT is a massive dataset aggregates global news every 15 minutes. By filtering cultural keywords, we generated country-level cultural news count and used them as a measure of cultural exposure. We initially attempted real-time collection, but the 15-time files were too small. Receiving even 10 gigabytes would take over a year. Therefore, we switched to a batch ingestion of historical files. Next is flight data. It reflects international mobility and potential cultural contact. The OpenSky API provides the origin country for each aircraft, allowing us to compute outbound flight count per country. We collected this data using our automated script, flight crawler, and store the results in HDFS and Hive. Next is when loading detailed data into Hive, GSP is errors produce morpheme columns such as C0 and C1 only. Moreover, country names differed across datasets, making joins impossible. Thus, in the stage layer, we perform country normalization, areas mapping, and schema correction, then produce a unified final tables. Next is we initially considered NetRedis as the analysis engine, but its heavy disk I/O and debugging difficulty made it impractical. We therefore adopted Spark, which is in memory faster and provides a flexible data train API. Next is, but however, Spark inside the Hadoop VM was fundamentally unusable. The Spark version was 1.03, which does not support Spark session. The VM only had Python 2.6 and 2.7, and the Python 3 could not be installed. The YARN repository was EOL, so Python 3 packages were unreachable. As a result, VM-based Spark analysis was abandoned, and we migrate entirely to a local modern PySpark environment. Next is our cultural engagement index was generated by filtering GDAL. GDAL for culture-related news events and aggregating them at the country level. This index was later combined with flight mobility and Wikipedia content volume to compare cultural mobility patterns between countries. Next is in the local PySpark environment, Spark sessions work correctly, allowing us to normalize flight data. standardized containment and joined the population data. The results were exported as CSV file for the Python visualization stage. And next, we visualize the relationship between cultural mix volume and flight mobility using like standard bubble chart and log scale bubble chart, and finally box plot chart. Among these, the box plot delivered a clear list insight by segmenting cultural needs to quantile. We could clearly observe distribution and outliers in flight mobility. Next, based on the box plot analysis, countries with higher cultural mix exposure tend to have higher flight mobility. We also identify outliers such as global aviation hubs and countries that with high cultural activities but low international movement. Overall, this appears to be a meaningful relationship between cultural exposure and international mobility. And finally, our pipeline consists with 5 layers. Each layer has design and directly responds to issues encountered during development, results in a practical and problem-driven architecture.
Okay, this time we'll move on to our another type of data, which is Wikipedia dump. We wanted to use some we want to use Wikipedia dump to analyze the length of article and the number of links, and to see where each pages were generated. And with the keyword related to history, such as art, cinema, heritage, and so on, we were also able to see how many pages related to culture were tagged with each country. So this was the pipeline that we planned. So it begins by downloading the dump with CURL and uploading it directly to HDFS. Hive is used to extract insert value block from the SQL dump. Spark then converts this raw value tuples into structured columns and perform normalization and map categorize and countries. However, the Wikipedia number consists of thousands of irregular insert and value statement. It makes it unsuitable for high parsing. We tried in many different circumstances, such as in local, in WSL, in VM, and even in Google Colab. And we used many different ways to load data, like loading from local and send it to HDFS, and load in HDFS and send it to local. But due to the characteristic of the Wikipedia dump data, we faced many problems, and Hive could not reliably extract multiple tuples per line, and its relax function captured only the first tuple due to inconsistent value structures. As a result, Hive was used only for raw text loading, while tuple extract should be shifted to Spark, which ultimately served as a supplementary tool. But due to the big due to the size of the data, Spark took so long to process, and that we were not able to make a result.
Yeah, next we gathered some data in OpenStreetMap. So we through OpenStreetMap we tried to gather the information about the cultural facilities such as museums and parks. And so we initially tried to load some original OSM PF files directly into Hadoop VM. However, this has this limitation issues because we have only 8.4 gigabytes on VM storage, so we cannot load or decompress PBF because it is over 65 gigabytes in total. And also we have compatibility issues because in VM there is Spark 1.3, so it cannot parse nested PBF. So we just adopt a hybrid pipeline. So locally we did heavy parsing and filtering on our own and convert PBF to lightweight format, which is GeoJSON SAQ. So we uploaded only reduced and ready to ingest data to VM. And next, we try to collect some data through GeoJSON SAQ. So the source data is pre-filtered OS cultural POIs in GeoJSON SAQ format. So we use Asia, Europe's, and North America's data. So the pipeline is we start at local VM and through HDFS, and we go to Sparks and Hive. So we place source files So we place source files under the home training files in local VM, and then we load it into HDFS. Okay, next. So we create raw layer creation, which is a parquet. So the input format is GeoJSON SQ, which has one feature per line and which is a nested JSON file. However, due to Spark 1.3 limitation, we just use legacy API. So we use SQL context points JSON file to load JSON into the data frame. And key columns. Then we select the attribute, flattened SCG layer. So remove unnecessary tags and we select some country tags and facility tags and year tags. So we made some OSM flat table based on this. So next, we use UDF-based features engineering because Spark 1.3 lacked when using because it doesn't provide when or otherwise. So we use Scala UDF instead. So first we normalize about country. Then we extract years. We did year section. We extracted 4-digit years from start year, historic year, and design year, and returns first valid year. Then and the facility classification. So we get some cultural types about this one. So for example, cinema goes to amenity, and the museum goes to tourism, and the theater, other center, gallery is to go to specific category. Next. So we get some final data frames, which includes all country, year, and facility types. So we count all the datas which has country, year, and facility. So next, we output the design for this data. So aggregate the data. So we try to just aggregate using Spark. So the output schema is country, year, and facility type and count. So we try to save as CSV or Parquet for visualization. However, due to time constraints, this high table creation was skipped.
Okay, so let's move on to visualization part. So these diagrams indicating how to calculate and combine each dataset related to economic status. There are like 4 components you can see: economic source and social score, cultural score, and trend score. Each index is normalized using statistical scaling and combined to produce a composite ranking. And this approach allows us to objectify compare cultural engagement level with economic performance. And this is a website that we built to show a better view of our economic status research after computing culture and economical like indicator. We normalize country names and merge both dataset, and this gives us a unified table where each country has a cultural score, economic score, and is relatively rank in both dimensions. This merged dataset this margin dataset is a foundation for the correlation analysis. And we're providing another website that shows the combined combined graph of economy status values and culture data. This one is about flight log, and this one is about total culture news count. And then we wanted to find the correlation. So when we plot the culture score against like economic score, we observed some like weakness, but noticed a positive correlation. We made with this pipeline, we were able to make this table. So if we combined, this became our final visualization result. We can see that there are like several interesting factors. For example, this is noticeable that United States had like really high culture influence with a bit low index for like while it's not like number one for economic index, and Japan and Korea had like social strong economy with vibrant culture activity, and United States had like high culture output while the economic metrics was not so outstanding. So we were with this final result, we were able to see some of them. This is the end of our presentation. I hope you found our research interesting. We'll also put our manual, so please take a look at this, please. Thank you so much.
And lastly, we are going to show our website that we made quickly. First, I'm gonna show the website, unified country ranking. So you can first see rankings and also full rankings. And by category, you can see each other and you can see what's the data source. And if you see the detailed source, there's metric, which is for each of the country, there's stock return, company average, currency, and so on. South Korea did first in economic ranking, so we were actually also really interested in. The main factor was because of stock return 1 year. South Korea's you can see this is very strong right now. South Korea's cost showed very rapid increase for 1 year, and you can see each of the detailed data for 49 columns. And for the ranking, it could be differ by the weight, but yeah, anyway, we kind of made summarized index that we can rank each other countries.
Okay. Let me show on our additional website. So first, this shows each final consumption of the value. The index are shown here. So this is like a final result of our economy analysis. And the cultural tab, we can check the flight log per capita. And if you put your cursor, you can see more information. And you can also zoom in and out. And this is the total, the news chart that we used GDELT. And we can check that the United States had very outstanding index. And by using those data sets, we made this final result. You can check the tendency, and you can also check the status of each